Every polynomial can be reduced to a set of positive prime factors. Factoring is the systematic process of identifying exactly what we multiplied together. Looking at an expression like 3x to the fourth minus 3x to the third minus 36x squared, the path to a solution isn't immediately obvious. On a test, the sheer number of variables can make it difficult to know where the first step actually begins. We are going to dismantle this problem using a 4-step checklist. By the time we finish, you'll reach the complete factorization in under 6 minutes. To understand the logic, think of the distributive property in reverse. If multiplying terms combines them into a single expression, factoring pulls them back apart to find those original pieces. We will use a dedicated checklist to track our progress, starting with a blank template that will fill as we move through the problem. Using a predictable workflow turns a complex arrangement of variables into a manageable logic puzzle with a guaranteed solution. Step 1 is the mandatory first move for every problem. Always check for a greatest common factor. In 3x to the sixth minus 9x squared plus 3x, every term shares a 3x. This commonality allows us to pull it out of the main group, placing it in front of a new set of parentheses to hold the remaining terms. A frequent error occurs when the final term is factored out completely. Leaving a blank space changes the expression's value. We place a positive 1 in that spot as a placeholder to ensure we return to our original polynomial. Factoring out the GCF first immediately simplifies the numbers you have to work with for the rest of the checklist. Step 2 applies when you are facing 4 terms. In this case, we use the factoring by grouping strategy. For x to the fifth minus 3x cubed minus 2x squared plus 6, we split the polynomial into 2 distinct halves. We find the common factor for each independently. On the left, we pull out x cubed. On the right, we factor out a negative 2. Extracting a negative from the right changes the inside sign. Plus 6 becomes minus 3. The grouping succeeds because the remaining parentheses match exactly. We combine these factors for the final answer, x squared minus 3 times x cubed minus 2. This strategy is effective because it forces a 4-term expression into 2 symmetrical, manageable parts. Step 3 covers quadratic polynomials, those where the largest exponent is a 2. With x squared minus 10x plus 24, we need to fill 2 sets of linear parentheses. Since the first term is x squared, each factor begins with an x. The missing numbers must multiply to positive 24 and add to negative 10. Testing the factors of 24, we find that negative 6 and negative 4 satisfy both conditions. We plug those into our blank spaces to complete the factorization, x minus 4 times x minus 6. Factoring quadratics is a logic puzzle. Once you satisfy the multiply and add targets, the result is mathematically certain. Step 4 is the search for special forms. When you have only 2 terms, you check for the difference of squares. The expression 25x squared minus 9 fits this template, as both terms are perfect squares, separated by a minus sign. Following the formula, we take the square roots of each to reach the factored state, 5x plus 3 times 5x minus 3. This logic does not apply to the sum of squares. An expression like a squared plus b squared cannot be factored using this formula. Before finishing, you must perform a final check. We look at our factors to see if any of them can be broken down even further. Take x to the fourth minus 16. Our first pass gives us x squared plus 4 and x squared minus 4. The first factor cannot be reduced. The second is another difference of squares, which we factor again into x plus 2 and x minus 2. This final check ensures your polynomial is completely factored into its prime elements. Now we apply the full checklist to our original problem, 3x to the fourth minus 3x cubed minus 36x squared. Step 1. Factoring out 3x squared leaves x squared minus x minus 12. For step 3, we need numbers multiplying to negative 12 and adding to negative 1. Negative 4 and 3 work. The expression is completely factored, 3x squared, x minus 4, and x plus 3. You now have a repeatable system for any polynomial problem. Screenshot the completed checklist and try the practice problems below to master the workflow.